Hello friends, this is Mohammed Reza Kachuyan, technical expert at Radonix. Welcome to part 3 of the Radonix controller installation and setup tutorial. In this session, we'll look at the menus and buttons on the screen. We'll also review the most important software settings step by step. Keep in mind, different interfaces may have different settings. Here, we're focusing on the 3-axis interface since it's the most common. Let's start with the software environment. In the bottom left corner, you'll see the Open button. Clicking it lets you load a G-code file or a DXF file. Once loaded, the workpiece dimensions appear at the top left of the screen. You'll see X, Y, and Z dimensions and the total work length. Hold the right mouse button to rotate the view. Hold the left mouse button to drag the screen up, down, left, or right. In the bottom right, there's the Exit button, which closes the program. Important. After changing settings, always click Set, then OK, then Exit. Close the software, reopen it, and your changes will be applied. Next to Exit, there's the Minimize button. This hides the software to the taskbar without closing it. The Settings menu is the heart of the program. All machine behavior is controlled here. Next to Settings, you'll find the Debug form. Double-click to open it. Here, you can check software version, interface type, and error messages. For example, it might say Radonix CNC Pro, version 1386. Errors and alarms are shown in this window. You can also open Debug form using the shortcut Alt, Control, Shift, and Print Screen. At the top of the screen is the online light. If it's on, the controller is connected to the computer. Next to it, you'll see lights for the X, Y, and Z axes. If a light is on, that axis is active. The alarm light shows errors with motors or drives. When an alarm occurs, the light turns red and an error message appears at the bottom. You can check the debug form to see the cause. Emergency inputs are also handled here. They may come from mushroom buttons or feedback signals. For example, you might see an error from input number 9, emergency ASF9. In the top right, you'll see absolute and relative coordinates. Absolute shows position from the home point. Relative shows position from the reference point. Some interfaces also display velocity here, which shows motion speed. The home button sends the machine to its home position. The speed of homing can be adjusted in settings. It's recommended to keep this movement slow and smooth. Below the home button, there is another button that moves the axis rapidly to machine 0, ignoring homing speed. The next button quickly sends the axis to the workpiece 0 point. The stop button halts machine movement. 3 buttons. X0, Y0, and Z0. Set the current position as the reference for each axis. Below the stop button, you will see 3 parameters for manual jog speeds of X, Y, and Z. For example, if you set X speed to 300 mm per second, then press Enter and hold jog X. The axis will move at 300 mm per second. The step parameter defines the amount of movement per single click on any of the axes. First, switch the motion mode to dashed line. When the axes are in incremental mode, shown as dashed line, entering a value in the step parameter causes the axis to move exactly that amount. For example, if you enter 100 in the x-axis step field and press Enter dot, each click on the jog X plus or jog X minus button will move the x-axis by 100 millimeters. The buttons X plus, X minus, Y plus, Y minus, Z plus, and Z minus each move the axis in their corresponding directions. When the motion mode is incremental, the percentage shown on the scroll bar next to the Z plus or Z minus button is multiplied by the step value. For example, if the step is 100 millimeters, a single click on jog X plus should move 100 millimeters. But since the scroll bar is set to 80%, the axis will actually move 80 millimeters. However, when the motion mode is continuous, shown as a solid line, the scroll percentage affects the axis speed instead of distance. For example, if the x-axis speed is 500 millimeters per second, and the scroll bar is set to 80%, the final speed will be 400 millimeters per second. The spindle button turns the spindle on or off, and its speed can be adjusted using the scroll bar next to it. The scroll bar next to the play button adjusts the program execution speed. The Tool and Set tool buttons under the Spindle section are for tool change operations, which will be explained in detail later. In the tool number field, you enter the tool you want to call. The Set Tool Length button is used to calibrate tool height. This concludes part 3 of the tutorial. We hope this section was helpful and well received by all of you.